Okay, so let me go through quiz 2 with you so that you have the key and you can see how we solve the problems. So the first one, which wavelength is of higher energy? So you just have to know, in this case, UV versus IR, which one is of higher energy, and that's the UV region, so a wave in the UV region. Which wave is of higher energy? So given frequency, so just compare the two frequencies. As frequency goes up, energy goes up. So that would be the one of higher frequency. And then in comparing these two for number 3, we have a frequency and a wavelength. So we need to convert frequency to wavelength or wavelength to frequency for one of these. So to do that, we need this equation. Speed of light's frequency times wavelength. So if we solve for the frequency, speed of light divided by wavelength, so 2.998 times 10 to the 8 meters per second, and divided by 3.0 times 10 to the minus 6 meters. That will give you that would give you 9.99 times 10 to the 13. Frequency, which is less than the other one, so this was higher frequency, so that would be higher energy. Which one of the waves below is in the X-ray region? Which one's in the microwave region? Well, so this is high energy, and this is low energy. So we just need to solve for the one that's the lowest in energy, or the lowest frequency, or longest wavelength. So if we take this and convert it to wavelength instead. So let's see. So speed of light is equal to speed of light is equal to wavelength times frequency. If we solve that for wavelength, so 2.998 times 10 to the 8 meters per second divided by the frequency, 2.12 times 10 to the 11 megahertz. And then there is 10 to the 6 hertz per 1 megahertz. So if we solve that, 2.98 times 10 to the 8th divided by 2.12 times 10 to the 11 divided by 10 to the 6. So that equals, did I do this right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1 times 10 to the minus 9 meter. So that's, so let me check my math again, make sure I did that right. Yeah, so that's a shorter wavelength, so that's a higher energy. So this would be of higher energy. So that would be the one that's in the X-ray region. This is the one that's lower energy, since it's longer wavelength, so that would be the one that's in the microwave. So that would have been the correct answer. Okay, calculate the frequency of the following electromagnetic radiation. So you're given wavelength. So again, you just need that equation. So if you want to calculate frequency, so solve for frequency. So take the speed of light divided by the wavelength that's given, and calculate that out. that gives you 8.61 times 10 to the 21, so that's the right answer. Okay, so what is energy in joules of this electromagnetic radiation of this laser? So you need E equals h nu, that equation, but you're given wavelength, so you need to convert wavelength to frequency so that you can use this equation. So again, we need this equation. So wavelength is equal to c divided by frequency, and we can play it. We're given wavelength, so solve for frequency. So frequency is equal to speed of light divided by wavelength, and then we can plug that in here. So E is equal to h times c divided by wavelength. Okay, so h is 6.63 times 10 to the minus 34 joules times seconds. Speed of light is 2.998 times 10 to the 8 meters per second, and divide that by the wavelength that's given. That's 950 nanometers, but we need to convert nanometers to meters. So there's 10 to the 9 meters per 1 nanometer. Okay, so did I solve this right or not? Let me try again. What am I doing wrong? Oh, that's what I'm doing wrong. 10 to the minus 9 meters per 1 nanometer. Okay, so that gives you 2.109 times 10 to the minus 19 joules. So that's your right answer. Okay, which is the Dewar model of ruthenium 4+. So 44 protons, 4 plus charge, so it's got 40 electrons. So you need to make sure if you add these up, there's 40 electrons. So that would be 12, 22, 32. This is 44 electrons, so that can't be right. And if we add these up, that's 20, 30, 40 electrons. This could be right, except for if you remember the second shell. Well, first shell can have 2 electrons. Second shell can have 80 electrons. Third shell can have 18 electrons. Fourth shell can have 32 electrons. So this would be the one. So 2 in the first shell, 8 in the second shell, 18 in the third shell, plus 12 more gives you 40 electrons. 40 electrons. So C, that's the right answer there. Okay. If the n quantum number of an atom is 4, what is L? So L can be anywhere from 0 to n minus 1. So if n is 4, then L can be 0, 1, 2, or 3. And if L is 3, M sub L can equal -3 to +3. So it would be that answer. Okay, so you have to recognize that is a d orbital, right? 4 of the d orbitals look like clover leaves, so that's a d orbital. And then you have to know if s, p, d, f. If L is 0, that's an s orbital. 1's p, 2's d, so L is 2. So L is 2 and d orbital, so that's the right answer. Here you have to recognize spherical is an s orbital, and if it's an s orbital, then that means L is equal to 0. So that's the right answer. Okay, so this, so L is 1 means it's a p orbital, and so it's a 3p orbital. So that's an s orbital, that's a d orbital, that's an f orbital, that's a p orbital, that's a p orbital. So B would be correct, or E would be correct. Okay, so selenium 34 electrons, B1s2, 2s2, 2p6, 3s2, 3p6, 4s2, so that's 10, that's 18, so that's 20, so 4s2, 3d10, so that's 30, and then after 3d10, you need 4 more electrons, so 4p4. So that would be this one. Okay, so iron 26 electrons. So iron would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So that would be 10, 18, 20, so that's 26 electrons. So what's represented here, so there's the core, that's argon. And then 4s2, so this can't be right because it's 4s1, that can't be right. So then this can't be right because you can't have electrons in the same orbital, have to be opposite spin. So then you're only left with 2 that are possible. And then if you remember, you don't pair electrons until you have to. So that would be the correct answer. So you put 4 in 4 different d orbitals, you don't have to pair any of them. Okay, so for number 16, so again the electron starts in the 4th shell, and it's going to emit energy, so again it's going to go down shell. It's going to give off energy, and short wavelength is equal to high energy. So then it's going to be n equals 4 to n equals 1 would be the biggest energy gap. And if it's going to give off energy, it has to go down, so 4 to 1 will be the correct answer there. Okay, so larger radius, it's O2 minus, right? If you add electrons, size of atom gets bigger. And so here, so then conversely, if you take electrons away, size of atom gets smaller, so which has a larger radius, so this would be larger and this would be smaller. Al3 plus would be smaller since it has fewer electrons. And in this case, since we're comparing 2 different atoms, so aluminum has 13 protons, oxygen has 8 protons, aluminum 3 plus then would have 10 electrons, and O2 minus would have 10 electrons. So which is larger would be the one that's got the bigger electron to proton ratio. And the one that has the smaller electron to proton ratio would be smaller. So O2 minus would be bigger. Larger ionization energy, so you just have to remember if you go across the periodic table, ionization energy goes up. So if we compare oxygen to beryllium, both in the second period, so oxygen is more to the right, so it's going to have a higher ionization energy. So which has the larger ionization energy? So if we're comparing carbon, nitrogen, silicon, phosphorus, so if we're comparing that, so nitrogen is more to the right, so that means it's going to have higher ionization energy, and also as you go up the periodic table, ionization energy goes up. So nitrogen is going to have a higher ionization energy. Okay, which represents a change in electron configuration for the ionization energy. That means it's going to give an electron away. So you can think of an electron as a product, which means that's wrong, and that's wrong, and that's wrong, because the electron's on the left of the arrow, so that would be, think of an electron as a reagent. It's going to be a product, so the electron has to be on the right side of the equation. And then, since it's titanium, it's a transition metal. So you have to remember those outer s electrons first. So in A, you lose an electron from the 4s, and in this one you lose an electron from the 3d, so you want to go with the one that lost the electrons from the outer s orbital first. Okay, so which is allowed? So if n is 1, L cannot be 2. Right? If n is 2, L can only be 0 or 1, it can't be 2, so that's wrong. If L is 0, M sub L can only be 0, so that's wrong. For D, if L is, let's see, that looks right. Okay, so here, what's wrong with this one? M sub S can only be plus 1/2 or minus 1/2, so that's wrong. And for this one, if n is 2, L can only be 0 or 1, so that's wrong. This one is right. Okay, how many orbitals in the second and n equals 2 have a value of m sub L is equal to 1? Okay, so if n is equal to 2, L can equal to 0 or L can equal 1. And if L is equal to 0, m sub L can be 0, or m sub L can equal -1, 0, or 1. So that would be 2 possibilities. Oh, sorry. It says m sub L can be plus 1. So that would be one possibility. Okay, so which subshell can only has 5 orbitals? So some subshell basically means m sub L, and means L. So if L equals 1, then m sub L can be -1, 0, or 1. That would be p orbitals. There's 3 p orbitals. If L is equal to 2, then m sub L can be -2, -1, 0, 1, or 2. That's 5. So we're talking about d orbitals here. So that L is equal to 2. There's 5 d orbitals. Which shell has 4 orbitals? So that would be the n equal to 2 shell, because if n is equal to 2, L can be 1, so that would be the 2. L could be 0, that would be the 2s orbital, or L could equal 1, so that would be the p orbitals, 2px, 2py, 2pz. So correct answer would be z equal to 2, has 4 different orbitals. Okay, so strontium's atomic number 38. And if you go backwards, so if you wrote this using a noble gas electron configuration, it would be krypton 1, 2, 3, 4, 5, 5s2. So krypton's the core. Krypton has 36 electrons, so the correct answer is 36 core electrons. Okay, 38, or 28. First ionization energy of potassium, so potassium is going to be losing the 4s1, 4s1, uh-oh. I think none of these are possible. This is a bad question. We'll have to 1s, 2s, 3s, 4s. Yeah, we'll have to throw this one out, because because it should have been 4, 0. N is equal to 4, L is equal to 0. We'll be talking about the 4s orbitals. So I was going for that one, but this should have been 4, so we'll have to give everybody credit for that problem. Which of the following orbitals is possible? So that's 2 doesn't have d orbitals. Only second shell only has p, s and p. Every shell has s orbitals, so that's possible. Third shell only has s, p, and d. So no g's, no f's at the third shell, and the first shell only has s orbitals, so that's not possible. Okay, cool. Chromium. Atomic number 24 would be 1s2, 2s2, 2p6, 3s2, 3p6. If it was normal, but it's not normal. If you remember, chromium is one of those that's regular, so its outer shell is 4s1, 3d5. So correct answer would have been that. Okay, so nitrogen 1s2, 2s2, 2p3. If we write it like this. 1s, 2s, 2p. Then you can see it's got 3 unpaired electrons. Okay, so which will be paramagnetic? So helium's 1s2, so that's full, so those electrons are paired. Beryllium's 1s2, 2s2. Those are both full, so those electrons are all paired. Sodium's 1s2, 2s2, 2p6, 3s1. So these are full, so those are all paired, but this is not full. So it's got 1 unpaired electron, so that's paramagnetic. And zinc and argon, all of their orbitals are totally full, so they would all have paired electrons. So none of those are paramagnetic, only sodium. Okay, and the last question. So electrons in the 4th shell, and it falls to the 2nd shell. So NF equals 2, NI equals 4. And to solve this, so what is the wavelength of the radiation? So what you have to solve for first is energy. Using this equation. Negative 2.179 times 10 to the minus 18 over 1 over n final squared. So 1 over 2 squared minus 1 over 4 squared. So that's n final, n initial. So solve for your energy first. So 4.0856 times 10 to the minus 19 joules. And then E equals H nu. So you can solve for frequency, but we can use this equation. So frequency is C over lambda, and plug that in here. No. What is the wavelength? Let's think. Yeah. So E equals HC over wavelength, and then if we solve this for wavelength, wavelength equals HC over E. So we can take the value of energy that you just calculated, plug it in here. H is Okay, so if you calculate that out, you get 0.123456 or 4.87 times 10 to the minus 7 meters, which is that for your final answer.